All right, almost done. Get this final show on the road here. All right, done. All right, so I guess I should have also had you guys looking for questions on the chapter 20 stuff.
Yeah, I got one whenever you're ready.
Which one? Go ahead. Which one?
Number 3 of the apply.
Number 3, apply. Okay, so let me get this up. Back here, do a little screen share. Let's see, efficient park.
Yes.
So let's see, we gotta get that out of the way. Stop share results. Okay. Suppose marginal private benefit of the park is that where A is the number of acres, the marginal cost of the park is 400. Consider a city of 100 citizens. The efficient park acreage is. So was it just the whole problem in general?
Yeah.
Okay. Who wants to share their work?
I have a good answer for part A.
Okay.
Part B is a little more complicated for me, but I have a good one for part A.
All right, maybe we'll try to work through part B together. We'll see what your part A looks like here. All right, Luke. Let's see, this is chapter 20. Just gonna be back here. All right, Luke. Okay. Here's your deal. Go ahead and verbalize through what you got here.
So basically, that question was trying to find the efficient park acreage. We're given, so that's going to be equal to the marginal cost. So I found out that 400 divided by the 100 citizens is going to give the utility needed for, or the, I think it was utility, the benefit basically from each person is going to be 4 to get to that marginal cost. So I did 400.
I think, hold on, let me just, that would probably be looking at the head tax maybe, or was that the 400? Because the benefit was the other function, right? This was your benefit function here.
Yeah, so I was basically finding the function needed per person, because to equal it to the marginal cost to find the efficient value.
Yes.
So you have to equal that to the marginal benefit, and to define it per person would be to divide it by 4, or for the curve that's given.
It's the marginal cost per person, though.
Yes, yes.
I think you said marginal benefit, but the 4 would be the marginal cost per person.
Yes.
Okay.
But so basically what I did from there was just I plugged that number into the formula, like setting equal to the rest, because marginal cost equal to the marginal benefit.
Right here, yeah.
Yes. And so that gets you 4 equal to 12 minus the A over 10, and then you solve that and you get A equals 80. And so that's your acreage. And then for part B, basically I attempted what the book said. It said it would be 1 more acre, and I got 9.9. So the overall benefit still goes down, but I guess they like rounded it up and said that people would still have a $10 net benefit. So that's what kind of threw me off, because I tried the 21, I tried 19, and it still didn't help it at all. And so I don't know where they got their number from.
Okay, so here's the part B. Well, first of all, is everybody, especially Daniel, I think you asked this question, did that make sense for the 80 being the efficient number for part A?
Yes, it did.
Okay, and is that the piece you were missing, was dividing the 400 by 4?
No, actually, sorry, I should have specified earlier. My question is actually on part B.
Oh, it was more on B anyway. Okay.
Yeah.
All right, so suppose the city tentatively decides on 20 acres. Describe a Pareto improvement in which each citizen gets the same benefit from an additional acre of a park. Okay. So Again, let's see, I gotta switch back to this. So Luke, with the one at 20, you did a marginal benefit, marginal cost, or what did you do there?
One at 20, I just pretty much put it in for the marginal benefit. So the 12 minus 20 divided by 10 get you 12 minus 2, which would equal 10. That would be their marginal benefit for 20 acres.
Okay.
And
So
then
that's 10. So they got benefit of 10 at 20, right? That's that number?
and then I just pretty much put in what they said the answer was with the one more acre getting $10 benefit still. And
Okay.
I got 9.9, and it's basically estimated that'd be 10.
Okay, so I think the only thing you're missing here is why, I mean, it goes down from 10 to 9.9. So is that making me worse off if I
Yeah.
go from 20 to 21?
Yes, and that's what was weird that it said one more acre in the
Okay.
answer.
So that's the part be careful with. If anybody else want to chime in, because that's the part, I think almost graphically it would help, but you're missing something of the argument here. What does an extra acre cost me? So the what is an extra acre costing me using the head tax formula?
Is it 0.1?
No, it's still what it is up here, right? Because it's constant.
That's costing you 4.
Yeah, it's costing you 4. So if I have 20 and it gives me benefit of 10, and now I think, oh, okay, well, what about 21? The benefit is 9.9. What's the cost?
4.
4. Is that a good deal?
Technically, yeah. I mean, you still
Yeah, more than technically, yeah. All we're doing is this. Marginal benefit, marginal cost. At 20, you're over here somewhere. And the marginal benefit is for the 20, and I should say the 21st since I put 9.9 up there. The 21st unit gives me 9.9 worth of benefit, and it costs me 4. So yeah, I'd want to do that. That's a Pareto improvement coming from 20. Even going to 22, benefit exceeds the cost, you should do it. So that would be a Pareto improvement. Where do we get rid of all the Pareto improvements? Right here at 80.
Gotcha.
Okay?
Yep.
Can you just really briefly explain what that a Pareto improvement means again?
A situation where you can make at least one person better off without making anyone else worse off. So
Thank you.
in this case, with an additional acreage, basically everybody's made better off because we have identical agents with the same marginal benefit function for this particular problem. Okay, anything else on this one? All right. Other questions on the homework?
Number 5. I wouldn't trust my answer, but number 5.
Okay. So basically this one here, let me go back to the question here. So number 5, fire protection. An upgrade of the city's fire protection system has an annual cost of $300, and it will decrease the probability that any particular house is destroyed by fire by that fraction of a percent, 1 in 1,000. For simplicity, assume that fire insurance is not available, and any house fire reduces the market value of a house to 0. There are 3 houses with property values of $100,000 for Wanda's house, $200 for Tupac's. Oh, we're bringing in an old rapper, Tupac, that got killed. That's cool. $300 for $1,000 for Trey's house. Is the upgrade efficient? Okay, an upgrade in the fire system has an annual cost of $300. Oh, okay, got it. So, what did you do? Sounds like we've got expected value stuff here as a possibility. So, annual cost 300. Go ahead and verbalize what you did, Luke.
I really had no clue on this one. I kind of put down what the book was suggesting and try to work backwards. And I really just have no clue. I put that the cost should be more equal to like what they pay should kind of be equal to what their house is worth. So basically
Okay.
to equal the amount. So Wanda would pay $50, Tupac would pay 100, and then Trey would pay 150. But I really don't know if that's correct or not. So.
Okay. Anybody else want to verbalize what they did?
I do have one quick question about the problem.
Okay.
Is it safe to assume that because of the way the problem's laid out, can we say that the liability is like half and half from the consumer to the fire department? Does that make sense?
No. So an upgrade in the city's fire protection system has an annual cost of $300, will decrease the probability for any particular house, which doesn't matter, of course, if it's a $100,000 house or $300,000 house. So it's the city that has the cost. And so where this one is headed is that the city's going to have to fund this $300 through a tax. And so the question says, there are 3 houses. For simplicity, assume that a fire insurance is not available and any house fire reduces the house to 0. There are 3 houses. So, was the upgrade efficient? So to be efficient, marginal benefit expected must be at least as much as the expected marginal cost. This is what we are head on in economics all the time. Like that's the thing, that's marginal analysis. It's a little more sophisticated when we have the expected marginal benefit, which is really more real world. So the expected savings is going to be different by the houses because it's the 0.001 times the property values. So from a public goods standpoint, let's see. So Luke, with your thing, you didn't do any probabilities. Oops, wrong thing.
I did not.
Okay. Whenever you guys see probabilities, you should probably shift into expected value mode. So when we got this decrease in probability, what is the expected benefit for Wanda? So she's got a chance of a fire, and the expected benefit is she's going to lose all of her house. So for Wanda, if you guys can have your calculators ready or a calculator, whether it's with your laptop, and go to the chat box, I want everybody to calculate this because this is the type of thing you'd need to do. We have a 0.001 for Wanda of saving $100,000 because there is no other fire insurance. So 100,000 times 0.001 for Wanda, and chat box says $100. Okay, so in theory, Wanda, it would be a fair bet for her to pay 100 to have an expected savings 100. That would be at least a fair bet for her to make. And then with Tupac and Trey, all of these numbers are just going to go up accordingly, 100, 200, and 300, just because of the math. So that's the expected benefit of the equation for each person individually. And here's the thing, with the single fire department, we have a local public good going on. So we could add those together to get the public benefit of 600. So we have a $600 benefit, and the question would be whether it would be a good deal or not. So from a public good standpoint, they should be willing to pay up to $600 for the fire station. But if they have to do a head tax equally, that'll be a raw deal for Wanda. And so that's kind of shows the inefficiency that could be created with the tax if they have an equal head tax. So what did the answer key have on this one?
It said yes, it was efficient.
Yes, that it was efficient, yeah. So it actually, there's even a Pareto improvement beyond that. But yes, that particular move makes everybody better off. The Wanda, it's a push, but it's still a good move. The marginal benefit equals the marginal cost. So she's no worse off for sure. And then it's a gain for these two. So therefore it's Pareto efficient move, Pareto improvement.
Did it get 600 because you added all three of those together?
Yes. So for a local, that was kind of back on the model where if we have a, let me just put, I'm just kind of making up an example here, but Wanda, 2-pack, and Trey, and we have a fire station. We have 2 fire stations. So the public good here is anti-firing stuff. At 2, the benefit to Wanda is, let's just say $3. I'm just making up numbers now. At 2, since it's non-rival, for 2-pack, it's $6, and for 2 stations for Trey, it's $8. And so the public benefit is the vertical sum of the individual people's benefits. And so the marginal social benefit, MSB, is at 8 plus 6 is 14 plus 3 is 17. So the social benefit of having 2 fire stations, sorry, I'm losing my thing. What the heck here? I hate that I hit that little tab with my fat finger. Oh, let's see. What am I on here? I can't even find where I'm at. What the heck did I lose? What was I writing on? Oh, Luke's thing. Oh, I think I just have to go back. I clicked the hyperlink. Let's see if this works. And it doesn't matter. We don't have to go back to Luke's anymore. But does that make sense? I was almost done with my drawing, but so this is at 17. So Olivia, does that make sense that we're summing vertically the benefits?
Yeah, it does.
Okay. And so that's what we're doing here with the 600 is we're summing vertical the benefits. And even with the head tax splitting the 300 equally, for this particular circumstance, it works out. So now to kind of push that a little further, if the fire system was 400, then Wanda would be out. That doesn't make sense for her if it's over 100. Her expected benefit is 100, but 400 divided by 3 is over 100 of cost if the tax is implemented that way. But now if we go to a majority rule, these guys still have it in their favor. So does this guy. So 2-pack and Trey vote yes, and Wanda would vote no. Majority rule would say we still do it. And so that kind of blends into the other topic of the chapter. All right, any other questions on this chapter's stuff? Okay, hearing none. So for the final exam, those are the things you need to do. You need to go back through your problems, and that's what I want you to focus on. So I kind of look back for this final and think, well, what do I want these guys to be able to do? I don't want you necessarily memorizing definitions and other things. So I'm going to really hone this in. You guys need to go through and work the problems, change the numbers. So on some of the back of the chapter problems, like challenge yourself to change a few numbers around and see what happens. But there's a lot of different ones. So you can focus in on the model. So what I want to do next is I'm going to go through the PowerPoints, which I posted in the announcements, should have came in your inbox as well, and do kind of a quick flyby of the chapter content and the models that we covered. So feel free to stop me as I'm going. If there's questions, I'll try to pause. But
hey, Russ, this final's like the whole semester. It's comprehensive, right? Is it everything, or is it just this section?
Just the second half since the last.
Okay.
So it's actually all the PowerPoints that I just sent out if you looked at those.
Yeah, okay.
So 10, 11, 13, 14, 15, whatever, those chapters are what it's going to be confined to. Now, of course, part of this built on the old material to some degree, but not completely. So there's a little bit of overlap that way, but otherwise, yeah, focus on these last chapters. Okay, so let me get my screen share back in action. Okay, so chapter 10 was really introducing, this is kind of an example where it was built, bringing in the model that we did before, or not the model that we did before, but the model that we built on in future chapters, like with the bid rent function. So the first section here is the willingness to pay principle on how much we would be willing to pay. And so you had a few problems like that, minus non-land costs, so that ultimately we could build this thing that we continue to use throughout the semester in different ways. Sometimes X was distance to highway, sometimes it was you know, something else, but we're always looking in, since this is spatial economics, like the distance away now caused a different willingness to pay, which we called the bid rent. In this case, it was bid rent for acres of land. But then we got into office buildings and all the other stuff. So it's kind of like a demand curve, but it's not, because we're thinking in terms of straight distances away. So that one, let's see here. I'm not gonna go through all my little extras that I have here. So this one was, where do we locate? So this was an important model that, again, we came back to before. It was first introduced, I think, here in chapter 10, although this one we might have even done in a previous chapter. But we've got a picture like this, and are we locating here or are we locating over here, which this thing's kind of in the way. But we look at minimizing our total cost. So there's a difference between, here we had 3 types of costs. We'd had other problems where there was only 2, but this is the freight cost to move our output. So if we operate at the center, then we have a freight cost going up to get it out, but our labor costs can be different too. And so, and then for this problem, we had an intermediate cost. So we added up all 3 of those, and we had this total cost function. And since total costs are cheaper at the from the center, then we'd want to locate the center. Other types of manufacturing, depending on if you're a weight gainer or weight loser, you might want to operate at the product market or input market.
Hey, Russ.
Yeah.
Can you give us an example of a weight gainer and a weight loser?
So furniture, you have to truck in raw logs for wood furniture. And so it's cheaper to ship the output during the production process versus the output. And so, but then it depends on the slope of the freight, like this problem right here, actually, Daniel, depending on what the freight cost is. So if you have a lot of freight costs, then this line could rotate up on you. And so then that could change your answer for labor costs versus freight costs. And so a weight loser would be like, and the textbook didn't always use the words weight loser, weight gainer. You just have to kind of think about where you're located and what the cost function is with each one. So, so we have the wood going into furniture. If we have something that we're making into a liquid, banana juice, I don't know why bananas come to mind, but maybe the output is now heavier because it's a liquid. And so we're selling banana juice. And so the output was weighed less from freight purposes than the output. And so then you might want to locate near the output market. But those change from time to time, but you should be able to look at this graph and kind of figure out, okay, there's my total cost. It's smaller here. So this is where I'd want to locate. My total costs are minimized here when I take into account my labor cost and my freight costs. Okay, any other questions on that? That's about it for in terms of the model for that chapter. Oops, let me change that. All right. Here's chapter 11. So this was locating near the center. If there was face-to-face interactions, the travel distance went up the more you were further from the center. And so if there's a lot of spillover effects or other considerations, then that's going to change the shape of your bid rent curve. So this is really applying to a different situation, our bid rent curves with office functions. So I walked you through some different examples. This is with factor substitution. Again, I'm not, don't go and memorize like, well, what was the factor substitution? Unless it was related to a problem. So I think you guys should really focus in on the problems, open up the problems again, try to rework them. A lot of them, you know, we gave opportunity to go over in class. So if you missed class on some of those review sessions, you might go back and review some of those. Let's see, this was the tallest building game. That there gets a point. Here's kind of a marginal benefit, marginal cost, like we were just doing, that the height of a building, eventually extra height doesn't give you anything, and the cost goes up higher. So we should have a shorter building. But there might be some additional profits for having the tallest building, was the one of the problems we went through. Let's see, this one, I think I just had a combination of old ones and new ones. Yeah, I went through my older ones with this one. So this is just the straight out of the textbook, the way they did it. So I'm just kind of breezing through. All right. Oops. Yeah. Okay, so now we've got houses. I think this one was a little more reading comprehension. I'm not sure we had a specific model. We'll find out here. Yeah, so this was the urban sprawl chapter. So you guys can look through your problems again, but if I remember right, you didn't even really have, maybe this was the chapter, I'm not sure if there was any problems, or if there was, they were pretty light. So if you come across that, that's intentional. I want you guys to know how to do some of these problems. So if don't sweat it if you run into that. Okay, and then the monocentric city we did get into. But you know, I don't want you going into memorizing that the omnibus happened in 1827. You don't have to worry about that for the final. Here was a combination of our bid rent functions. So how cities develop, that offices might be close to the center, then manufacturing, then residence, agriculture. So that's where we started building up. Here was again using that total cost model to motivate some of that. This one had the labor supply with the wages. So this had a connection, some of the homework problems that you had, the residents, and then we had the invention of the streetcar, which allowed people to move out further. So part of your problems had to deal with the bid rent function shifting out to the right, causing more residents. And then that could have some implications on the wages. And yeah, that was it for that. Chapter 15 on neighborhoods. So we had some fun maps there. This was the one where how people are spread out through the city. So do people tend to segregate in terms of maybe the high income area and the low income area of town? To what degree do they do that? So you can review this if you want to check out the, some of the math for the degree of dissimilarity. I tried to walk you through a few different problems there. I don't think we had it. I think they either gave you the dissimilarity index. I don't know if in your problems you had to work that. Again, for the final, if you work the problems and know the problems well, that's what I want you to be able to do. So you can kind of focus your efforts there. You don't have to memorize this formula if it wasn't used in the problems. So this was data on segregation. We saw that with local public goods, diversity and demand. Okay, here's where we got the one that you had some questions on for sure. So we were trying to establish if we'd get segregation or not. And so in a place where if the high income areas got the best schools or something, if the high income people can outbid the low income people, then a 50-50 split of having equal amounts of high income and low income people, is that a Nash equilibrium? Is it a stable equilibrium? And so we talked about going a little bit to the right. Now all of a sudden high income people can start outbidding the low income people, which is going to make S, which is the fully segregated outcome, a Nash equilibrium. And so we get full segregation when the preferred group, the high income group, can outbid or does outbid, has a preference to outbid. But that's not the way all of them need to be. So it is possible to have the low income people be willing to pay more at the margin for a particular good. Just because the high income people are there, maybe the high income people don't have any kids, for instance. And so their lower income people are willing to pay more for housing in a particular area than the high income people. So don't think that just because the high income people are there that they wouldn't be willing to outbid at the margin. So if we have the case where the low income people are the higher bidders, then if we move out here, there's going to be more low income people moving in, which is going to push the high income people out, which moves us to the integrated outcome of 50-50 being a stable outcome. And then one more, and I'll pause for questions on this one. They can look like this as well. So here we have the high income people at first above, but then it changes. Like when there gets to be a lot of high income people, then low income people really want to be in that neighborhood. And so if that's the case, we might see a composition of neighborhoods where it's 70% high income and 30% low income. And that would be a stable outcome as well. All right, 10-second pause for questions there.
Wouldn't the low income people, like, wouldn't the houses still be expensive? So are they just willing to pay a lot more because of that?
Yeah, they can just change around their budgets. So when we say low income, we're not necessarily saying people in poverty that are on food stamps, but it might be, let's say, a $60,000 combined income versus a $100,000 combined income. It's possible that the lower income people could make it more of a priority to live in that neighborhood. And so they're going to shift their budget accordingly and give up going on vacation an extra year and give up, a couple other things in life so that they can buy the house in the high income neighborhood. Does that make sense? Okay, any other questions? All right, moving along. Let's see, I think that was pretty much it for that one. Yeah, I just had a few other. It's kind of the main model there. Land use. So we had zoning. We talked about the city map for Ottawa. This was a little rule of thumb on kind of city budgeting, on them trying to get so that they don't have a fiscal deficit. This was the model that we had from previous chapters that we brought into this one with the mobility of people, moving from a city that does something versus a city that does not. And so the thing to remember with this model is we've got two workers of, like, let's say equal size. What's going to happen if one city changes? Well, they're going to be made better off, but then people are going to vote with their feet, the Tebow model that we had before. And so as they start to move into this city, they're leaving this city. And so we end up getting equalization of utility as the Nash equilibrium, so that people are indifferent between living in city A versus city B. So growth boundaries, if we set a fixed amount of land and we don't allow a city to grow any further, what happens to land prices? They go up. So if we don't allow growth to be further than 8 miles from the center, then we have this kind of uptick in demand because everybody needs to go there, and it leads to expensive housing. That was kind of the moral of the story there. There's the utility one we kind of already talked about with people moving around. Building permits. So if the city's trying to control growth of the city through use of building permits, then if only 80 permits are allowed and they'd like to be in a free market 120, we're essentially moving that supply curve up, driving up housing prices. And that caused, so that's kind of, it's really the same graph that we used for like quotas in different classes, in principles class, of what the effects of a quota. And then housing regulations. So regulations on housing make housings more costly. And so this is basically the marginal cost curve when we think about the supply curve. And so those houses are going to be more expensive, which again is going to drive prices up for housing. All right, yeah, that was it for that one. 10-second pause for questions. All right, cars and roads. So we've got traffic and congestion. And so here the focus was more on externalities. And so we've got the social cost being higher than the private cost. And so in the market, in a free market, there's going to be essentially too many people on the roads if the roads are free because they're not taking into account that they're causing congestion for other drivers. And so society's optimal amount is where the social cost and the social benefit curve intersect, which is just the demand curve if there's nothing on the consumer side. And so there would need to be less taxes. And how can we do that? Maybe we can get some toll roads going and other things was the direction we took things here. So implementing a tax. So the one part I might highlight here that I think you saw in some problems, that the vertical height here is the amount of the tax per unit at the efficient level for the road. We use this graph again with the utility analysis to think that if a city implements toll roads and now it's more efficient, what would be the transition that we'd expect? So we kind of had people moving to the city where it's more efficient, but then that of course adds more congestion until the utilities are equalized. So same story we told
Russ, I have a
earlier.
quick question.
Yep, go for it.
So congestion tax, does that make the externality go up or down?
It makes it go away.
Oh, okay.
So with the congestion tax, in theory, by the way, that this is the part that we don't really have enough information. It's one thing for us to do this on a textbook way, but if we implement the tax here from this picture, this is the efficient level, right? Because that's where the social benefit and social cost curve intersect with each other. And so by implementing the toll tax, we get to that amount of traffic. Now the government's collecting some tax revenue equal to that. So what they're doing with the tax revenue and other things, that's where a more general equilibrium analysis would lead to something different. But in general, we got rid of the deadweight loss by implementing the tax according to the model.
Okay. Thank you.
Let's see, this was on off-peak pricing. So we talked about the toll, the roads, the high occupancy roads, and different policies, and checking out the benefits. So I think some of your problems had to do with time costs and analyzing who would be made better off or worse off. Let's see, and that's again with the toll. This is with the high occupancy lanes. These are really all just tweaks of what we did before in terms of how that might get us back to equilibrium. This one, I think we had a couple different problems, maybe even in different chapters. So this formula is kind of handy with the burden of the tax to the consumers is always the sum of the elasticities in the denominator and the elasticity of the other group in the numerator. And then that'll show you the share of taxes that they have for whatever tax was implemented. We learned that we kill people by having airbags because people drive more recklessly, and we might have less deaths in the car, but pedestrians might be put at harm. So kind of shifting around these costs. So with airbags, the cost actually went down. So cost went down, causing more people to go faster, causing maybe people on bikes and other pedestrians to be more in harm's way. Might have been one of the unintended consequences. Okay, almost done here. Let's press on. We'll just probably do this one since we just got done with the role of local government. So here's the crime stuff. The rational criminal, I'd say this is the key model, that you've got the outcomes. So this kind of ties in with some other problems too. This is always the same formula. So remember we had like the 3/5 of a chance of getting 120 and 2/5 of a chance of getting 25. And that gives you the expected marginal benefit essentially of doing the crime. And then we compare the benefits and the costs. So with this chapter, we started looking at altering prison terms and other things. So we had the gains, the benefits of utility of cash coming at less of a rate than the loss. So the slope of this utility relationship, for gains it was 3, and for losses it was 6. So losses hurt more than gains is why we have the shape of that. So we calculate the expected benefit, the expected utility, and then that gets translated into the certainty equivalent. And then we did all those different types of problems saying, well, what if we did this? What if we changed the loot? What if we increased the probability of getting caught? So all the rest of these slides really go through different scenarios of what if we put people in school, then the lawful wage goes up, crime goes down. What if we put more police officers out there? Then the probability of being caught goes up, the loot goes down, the certainty equivalent, right? So we just kind of work through all of those scenarios with this model. So definitely kind of understand the details of that, work through those problems, work through these slides if you need to again. And then this thing closes out looking at the efficient level of crime. Most people would say, oh, we don't want any crime. Or so here's more relevant for you. Some people would say, we don't want COVID. We need a 0 chance of getting COVID. Well, what's the cost of that, right? So there's costs that might be, at least in my humble opinion, costs that are exceeding the benefit of keeping the economy closed at this point. Now with the information that we know and that our health facilities and human resources related to treating people who do actually get sick, now that those are more freed up, are we reaching a point where the cost of keeping the economy closed is greater than the benefit, expected benefit? And that's the part about the expected, right? What's true about these probabilities and how people will do. You had a problem with robberies versus burglars and carpenters, and so the efficient or the rational criminal, depending on the profit that they're going to make, is going to make these decisions. So one of the consequences of making burglary harsher penalty, it's going to lower the profits here, but some of those people are going to become robbers. Some of them are going to become carpenters. So we had a couple problems like that. All right, looks like I kept you a minute over. Any questions?
How will the test be conducted? Is this going to be online or?
I will send out, I'll send out more information on that. I think that's the direction I'm heading. It's definitely going to be during the exam time of 10 to noon on Friday is the university exam time. So be ready for that. And then I'll send out more information. I have that order in with the OU help desk, and we'll see how exactly it'll be administered, and I'll give you more information in an email. Anything else?